Distance of closest approach. Here we have Rutherford atom model. Most of the alpha rays simply passes through these atoms. Few alpha rays suffers small angle deviation. Very few alpha rays suffers very large angle of deviation. What happens if an alpha particle heads straight for the nucleus? Does it hit? Look at the diagram. The alpha rays goes, it stops momentarily at a distance and returns. No, it stops at certain distance and bounces back. The distance we call it as R0, the distance of closest approach. Let's find why. Definition. When an alpha particle moves directly towards the nucleus, it slows down due to electrostatic repulsion. When an alpha particle moves directly towards the nucleus, it slows down due to electrostatic repulsion. At a certain minimum distance, it stops momentarily before bouncing back at 180 degree. At certain minimum distance, it stops momentarily before bouncing back at 180 degree. This minimum distance is called the distance of closest approach R0. At R0, the entire kinetic energy of the alpha particle is converted into electrostatic potential energy. Concept. At R0, the distance of closest approach, kinetic energy of the alpha particle is fully converted into electrostatic potential energy. So the formula for kinetic energy is half mv0 square, whereas the electrostatic potential energy is 1 upon 4 pi epsilon naught q1 q2 divided by R0. Kinetic energy is half mv0 square and potential energy is 1 upon 4 pi epsilon naught 2e Ze divided by R0. 2e is the charge of the alpha particle, Ze is the charge of the given nucleus. On simplifying, R0 equals 1 upon 4 pi epsilon naught 2 Ze square divided by half mv0 square. From this equation, we can write R0 equals 1 upon 4 pi epsilon naught 2 Ze square divided by the kinetic energy Ek, where Z, atomic number of the target nucleus, Ek, kinetic energy of the alpha particle, E, charge of the electron. This equation tells us higher the kinetic energy, we get smaller the distance of closest approach R0. Higher the nuclear charge Z, then we get larger the distance of closest approach R0. Using this formula, Rutherford estimated nuclear size. Nuclear size means nuclear radius. Nuclear radius is different from distance of closest approach. Nuclear radius is always less than distance of closest approach. But remember, nuclear size, that means nuclear radius, is always smaller than the distance of closest approach R0. For example, nuclear radius lies between 10 power minus 14 meter and 10 power minus 15 meter. NEET tips and recap. R0 decreases with higher kinetic energy. R0 increases with larger atomic number. Nuclear size is always smaller than R0.